morning class, or afternoon, or evening, whatever it is. Today, basic principle of biology, okay, how life comes about. Started back with probably our friends, the cyanobacteria, the first photosynthesizers who created oxygen by photosynthesis. So it's the reason we're here today. It's the reason we have oxygen. It's the reason that we can capture energy from the sun. So let's dig into it. All right. So appropriately, I'm in front of the garden here. Of course, we got nice green plants here, which are photosynthesizing as we speak. All right. So photo light making energy from light. All right. Here's the basic formula. Okay. Carbon dioxide plus water will make glucose and oxygen. And of course, this delta G is going to be a positive. So you guys know that is endergonic. Okay, 686 kilocalories per mole. Right. So how does it do this? What drives the reaction? Well, of course, it's light. And you probably recall from your earlier science days, light is just one form of electromagnetic radiation, okay, which is wave-like energy, okay, which travels through space at the speed of light, speed of electromagnetic radiation, which is 3 times 10 to the 8th meters per second. Okay, so very, very fast, 186,000 miles per second. Okay, and that equals the wavelength, okay, times the frequency for all these different forms of electromagnetic radiation. All right? So we have, starting with the shortest wavelength, highest frequency, we have gamma rays, X-rays, ultraviolet. Then in the middle we have light, okay, just right light. Then we have heat or infrared, and then we have radio. Okay? So we go from having very short wavelengths, high frequency over here, okay, to very long wavelengths and low frequencies over here. Okay, really high energy here. Higher the frequency, the higher the energy. Okay, so of course this causes radioactivity causes mutations and so forth. X-rays damage your tissues. Ultraviolet rays burn you. Over here, infrared, that heats you up. Radio waves, that transmits information, doesn't really damage you. Not much energy there. But light's got it in the middle there. See, it's just right for our planet. It's got enough energy to, as we'll see here in a few minutes, it's got enough energy to excite electrons, okay, but not so much that it destroys tissues. Okay, so it's just right. Okay? So how does a plant do this, or how does specifically a chloroplast do it? Remember, a chloroplast is that organelle inside of a eukaryotic cell. Okay? Cyanobacteria just have it in their membranes. Here's how it's organized. So this would be one of many chloroplasts inside a plant cell, like a mesophyll cell or bundle sheath cell in a plant. Right here. All right. So it's organized in this what are called grana. Grana are these membranes piled up on each other, kind of stacked up on each other. So there's stacks of membranes. Remember, chloroplasts actually have a 3-membrane system: outer, inner, and then they have these thylakoid membranes inside. Okay, so the thylakoid membrane is kind of the functional unit. That's where all the pigments are located. Okay, and the pigments, of course, are colored compounds, colored molecules. That means they absorb certain wavelengths of light and they reflect others. Okay, so for example, a green plant, it's got a lot of chlorophyll in it. Okay, that's the pigment. Okay, chlorophyll absorbs best in blue-violet light and also red, and it reflects green. So that's why it's green. And again, that's why you see color changes. I don't see too many color changes here, but in the fall, I can see out there, there's some red leaves, yellow leaves. That's because other pigments are coming out because the chlorophyll breaks down sometimes. Okay, so major pigments, the primary one is chlorophyll A. There's also chlorophyll B. Okay. There's also xanthophyll, and then there's carotenoids. So these are different colored pigments which help absorb light. So when light comes in, okay, to the membrane is actually what picks up the light energy. Okay, they're organized in what is called a photosystem within that membrane. So a photosystem is this a collection of these pigment molecules, okay, which get excited, okay, by the light. Okay, so it's called the photoelectric effect. Okay, so light comes in and it excites these electrons. Okay, so like scanners, scanners, they use this photoelectric effect, but plants do this. So light would come in and it gets into this photosystem. And it's the analogy to like a billiard ball or pool table. When you strike that first ball, when you're breaking you have the triangle and you break it, well, it hits that first ball and then it transfers the energy to the other ones and they all kind of break apart. Well, it's the same thing here. Okay, this gets excited and it transfers energy here, transfers all through down to this tube. But when it gets to the reaction center, it causes this electron to jump up or get excited. So it kicks an electron out of a chlorophyll A molecule, okay? And then that can be picked up, okay, for by what's called a coenzyme. We'll get into that next time. So it kicks this electron up to a higher energy level, okay? And then this chlorophyll has to have that electron replaced, okay? And so this is a key reaction here. It comes from H2O splitting become H plus O2. Okay? So you create hydrogen ions, which are going to be really key in a few minutes. Well, in a few minutes when I do the next show. And also you produce oxygen. Okay, so oxygen's produced by this splitting of water. Okay, it produces hydrogen ions. It produces an electron, okay, to replace for the chlorophyll, okay, and oxygen. So that's how light energy is captured from the sun.